All right, welcome back. We're going to do Chapter 10, Section 3, Data Distribution, as well as Chapter 10, Section 4, Misleading Graphs. So if you remember the mean, I think of it as the meanest one to do. This is where you add up all of the numbers, and then you divide by the total amount of numbers. The median is where you put all of the numbers in order, and then you count to the middle number. And the mode, MO, most occurring. And there can be more than one mode, or there can be no modes. And the range is one number answer. It is the largest number minus the smallest number. It's always positive, and it's always one number. So we're going to recall box and whisker plots. And the first step is to put everything in order. If you notice these numbers are already in order, we'll do one in a little bit that they're not in order. So when we're counting to the middle, we are counting in, and our middle number is directly in between these two 19s because there are 4 on either side. So 19 is the median. The one median number we do not use. And then, to find the quartiles, we go to the middle of the lower data. So this is your lower quartile, or quartile 1, same thing. And then to find the upper quartile, we go to the middle of the upper data. So 26 is your upper quartile, also known as quartile 3. And then the smallest number is your lower extreme. And your biggest number is your upper extreme. So we would make our box and whisker with that data, which we'll do momentarily. In our next set of data, again, we're going to count to the middle. This time, 72 is our median. Again, you do not use the one median to find your quartiles, so I'm not going to use my one median number. 60 is my lower quartile. 80.5 is my upper quartile. 85 is my upper extreme, and 58 is my lower extreme. These are called quartiles because they're breaking the data into quarters. So this is the lower quarter of my data. This is the second quarter of my data, the third quarter, and then the fourth quarter. So this is upper quartile. Quarter is 4 parts. Okay, for the next, counting to the middle. So we're going to average this again. 8 is our median. And our lower quartile now is directly at 6. And our upper quartile, because we're not using the one median number, is directly at 14. This is your upper extreme. This is your lower extreme. These 5 numbers circled, as I circle my median, is called your 5-number summary. And the last one on this page, again, we're going to count to the middle. So 6 is my median. 4 is my lower quartile. 10 is my upper quartile. 13 is my upper extreme. And 2 is my lower extreme. When we actually get to making box and whisker plots, which will be in just a second, you have to have a number line, and that's where you plot these data. So if we just look at this last one, we would need to make a number line, maybe starting at 0. And if we're only going to 13, we could probably just count by 1. You want to do your best to make these evenly spaced. And you might want to go a little farther than the last data point. And I would put a dot at 2, a dot at 4, a dot at 6, a dot at 10, and a dot at 13. That is my 5-number summary. The middle 3 make up my box, like so, and the last 2 make up the 2 whiskers. So again, 25% of our data lies in this range. So if we had 100 data points, 25 data points would be in that chunk. 25% of the data lies in this range. So when the bar is spread out, that means the data is a little more spread out. There's still the same number of data in that clump, it's just more spread out data. So the central 50% of the data is important because it's half the data. And that's between the first and the third quartile. And that's called the inner quartile range. So if we go back to this, if we look at our last one we just did, our inner quartile range is from 10 to 4. So 10 minus 4 is 6. Our inner quartile range here, we can write that as IQR, would be our upper quartile minus our lower quartile. So that's 14 minus 6, which is 8. And the one before, our inner quartile range is 80.5 minus 60. And right here, our inner quartile range is 26 minus 18. It is best to write your quartiles as one number. So let's go ahead and solve those last two. 26 minus 18 is 8. So that'd be our inner quartile range. And then 80.5 minus 60 is 20.5. So we do want that as one number. Our inner quartile range is important because that's going to help us determine if we have outliers in our data. So to figure out if something is an outlier, remember there's 25% of your data in each clump. So each of these clumps has the same number of data in them. The tighter that clump, there's still the same number of data, so that number of data just isn't as spread out. So if we take our inner quartile range, and if we multiply that by 1.5, whatever that number is, if we take that number and subtract it from the lower quartile and add it to the upper quartile, that's going to be our good data. So let's go back to that last problem that we did on this first page, and then we'll do a more intense one. Oh boy. So since our inner quartile range is 6, 6 times 1.5 is 9. I'm going to take that 9 and I'm going to add it to my upper quartile, and I get 19, which is even farther up here. I'm going to subtract it from my lower quartile. So 9 less than 4 is -5. So all of my good data is between -5 and 19. All of this is good data. So in this case, I have no outliers. Which makes sense. The data seems pretty close. It doesn't seem like there is a number that's not quite right. All right, so we're going to make a box and whisker of this data. Our first step is to put everything in order. So we will do that. One nice way to put things in order is to, if you have a bunch of numbers, is to make a stem and leaf. In this case, we don't really have a bunch of numbers, but if we want to put a 1 and a 2, I know 20 is my last right here. I know 10 is my first. And then as I see all these, I'm going to try to put it in order like this with a bunch of spacing, which is not the proper way to make a stem and leaf, but that's okay. So 3, because it's not we're just making the stem and leaf to make our box and whisker. So we've got the 3, the 4, the 6. And then I've got another 3, a 2, and a 4 that I just crossed off. A 15 would go right here. A 12 would go right there. A 13, I'm going to squeeze a 3 right here. A 16 up here. 10 I already have because it was my lowest number. I have 2 more 14s, 1 more 15. I have 18 because it's my biggest number, or 20, and then 1 more 18. So in order, I have 10, 12, 12, 13, 13, 13, 14, 14, 14, 14, 15, 15, 16, 16, 18, 20. And if this was a true stem and leaf, I would have to make a key to show what that data means. But I'm just using my stem and leaf to get my data in order for my box and whisker. So once it's in order, the first step is to find the median. So we're going to count to the middle number here. And it's right in between these two, which is 14. I'm not using the 1 median number, so I'm going to now find the middle number of these 8 points. So it'd be right in between here, which is 13. That's my lower quartile. This is my lower extreme. These 8 points, my middle number is 15.5, so that's my upper quartile, and my upper extreme is 20. So on my number line, I need to go from 10 to 20. And you could start at 9, 11, probably just counting by ones. All right, so I put a dot at 10, and at 13, and at 14, and at 15.5, I might label that one since it's not perfectly visible, and then at 20. Making my box with my inner 3, making my whiskers, and then I'm looking for my inner quartile range. That's the range of my box. So 15.5 minus 13 is 1.5. I'm taking that 1.5 and I'm multiplying by that special number 1.5. You always multiply by 1.5 because 1.5 of this box taken and added and subtracted from either side should be a good amount of data range. So this is 2.25. So I'm taking 2.25, I'm doing my upper quartile plus my inner quartile range. So that would be 15.5 plus 2.25, which is 18. So that's the end of my good data. Now 18 is one of my points, and that is good data. So I'm going to end my box and whisker at 18, and then I'm going to put an asterisk at the outlier here at 20. If I go to my lower good data, the lower quartile is at 13. So 13 minus 2.25 is 10.75. Let's see. So again, I do have an outlier down here. Since 12 was the number before 10, I'm going to go back to my 12 and put an asterisk at 10. So I have two outliers, one in the beginning, one at the end, that need to be on there. And that's what a box and whisker with outliers looks like that I skipped. All right, and then the next section is about misleading graphs. And every single time you look at any sort of table or graph, people can make anything look like anything they want. They could make something increasing look like it's decreasing. So this looks like the trees are a pretty darn big difference. But if you look at the numbers, they're really not that huge of a difference. This started at 80. Typically when you don't start at 0, you need to put a tilde in there, that there was a jump in the graph. Whoops. So I got to move this down. All right, so if you started your thing at 0, if you look at it like this, there's not much of a change. So that's why this graph is a little bit misleading. It looks like there's a big change, but yet there's not. If you look at the second graph, let me move these yellow things down. We've got our average gas prices. It looks like we've got 93, 95, 97, 99, 2001. So we've got good increments here. But this is a difference of 10, and then it's increasing by 2s. So that right there is a misleading piece. So if you look at that without the jump from 10, it looks more like this. And again, there's jumps from 10 here and here. So you see how that changes to look like that. So where it looks pretty darn flat, it's actually pretty darn steep. You always have to number your axes with the same increment. You can go up by whatever you want, but it has to be the same number. The circle graph is a problem because all of those percents need to add up to 100%. So we are missing something. We're missing a lot because this is only 35. So where's the other 65? That is a good question. Definitely misleading. And then you need proper sample spaces. So if you have this situation where a researcher is surveying people leaving a basketball game about what they like to watch on TV, and it says 80% of people want to watch sports, well, your sample space is at a sports place. Maybe if they went to a non-sports place, like a restaurant, they would have gotten different data. And then researchers asked 4 people if they have seasonal allergies. 3 responded yes. And then the data says 75% of people have seasonal allergies. Well, you've only asked 4 people in your sample space. So if your sample space was bigger, like 100 people, probably that data would be a little bit different than 75%. That is all. Have a good night. I'll see you tomorrow.